Hi, welcome to IoT Labs. So, in the previous video, communication with the module TX pin is pin 9, means pin 9 of ESP32 we are using as TX pin. Pin 10 we are using as RX pin. This function is for sending the AT commands. Default wait time is 500 millisecond. If we pass any value, it will take it like that for the waiting period, and it will print the response. Then there is send MQTT messages, which will take parameter as topic and the payload. It will send the topic and the payload to the MQTT server to which it is connected. In the setup, you can see first it will initialize the serial port with 1,15,200 baud rate. Then we will initialize the another serial port with the custom name as A7670 on serial 8N1. RXT pin, TXD pin mentioned here. Then we will declare the pin mode for sleep and power enable pins, and by default we will make digital these sleep pin as high to take it to keep it awake, while we will make the power pin low for the resetting it. So if in case we reset it, since it is in case the ESP32 we reset, but the module is continuously getting the power, we have to first make it off and on to reset the connection. That's why. And then we will make the power enable high. So here the module is properly powered on and it's not in the sleep mode. Then I have made some 20 second delay. This delay is just for the testing. Later I will remove it and put the condition when SIM is properly prepared and network and all are properly connected. Then I will start the communication. Then you can see here these are the basic commands that are needed. Like first of all, we will disable the echo, then enable the GPS, check the device info. This is for right now, and for the testing we will remove it. Then it will check for the network registration, whether it is registered or not. Then we will start the internet, starting the APN, check the IP address. This I have done so that I can debug it easily if in case there is some issue in this testing of this module on the microcontroller, because right now we are not directly interacting it with it. We will just make the all commands in ESP in the firmware of the ESP, and ESP automatically will communicate with the module. So then we will check the IP address. Then it will start the MQTT, prepare the client and connect to the MQTT broker, and then MQTT setup is complete. So then what we have done is we have there is a AT command, which is since generally when this device is connected, on USB side there is different COM ports are there which are specific for sending NMEA NEMA data. They broadcast there continuously, but since we are using UART port, so we have to send the command, and then the module will return back the NMEA string, which will contain the coordinates and all. So after every 5 seconds, right now for testing I have made it 5 seconds, but later we will remove it, and we will be able to get continuous data from it. So for right now for the testing we will keep it 5,000 or 5 second, 5,000 millisecond or 5,000. And if the data is available from this module, then we will save it in a string that is response, and we will check if it is starting with the AT command that we have sent, like cgps info. If that string that we have received from the module is having GPS string, then we will parse it, we will trim it if there is anything like ending parameters are there and characters are there, so it will remove those empty character for easy for the parsing. Then there is the parsing rule is there, which will parse the enemy string. This is the complete string, which parse on the basis of the commas. Like first, it will have like generally the time it will have first time, then latitude, then longitude, and like that. Then it will give the direction, date, time, altitude, speed, and all. So it will save all the data in the strings, and then it will send the like uh, each of the parameter in its specific topic. So topic is track device 1 latitude, track device 1 longitude, track device 1 date, track device 1 time, track device 1 altitude, track device 1 speed, and like this. And it will do everything, and then it will restart again. Here I have added a code in which I can externally also provide the et command to the ESP32, and ESP32 will send that command to the A7670 module, and will read the response from it. So now I will plug it up, and then we will see how it will go. So let's begin. I plugged it in, and now I will on the serial monitor. Now let's see, it's started. So let's wait for those 20 seconds, and then it will start to print those values. Okay, yeah, you can see it now. Everything is initialized. It's ready. So as you can see here, it is continuously sending those AT commands C, G, P, S, I, N, F, O, but haven't received anyone. So it will continuously wait for it. So I have to take it out for a bit and in the open space, and let's see. So I will take the laptop like in the open space. So let's see, it will take around 1 or 2 minutes. So now I got the GPS satellites logged, and now can easily you can see I'm getting the NMEA string, and the data from it is continuously being passed. You can see here, this one is, wait, let me show you. This is the response I have got, the NMEA string, and then from it we have passed the latitude, and then passed it in via MQTT payload. We have passed the other stuff, longitude we have passed and sent it. Then there is date, time, the speed at which I am moving. Right now I am not moving, so it will be 0, but the altitude is also mentioned there, and you can see it is continuously being received from the GPS, and it is continuously passing to the MQTT mosquito server. And let's see it on the mosquito MQTT explorer. You can see here continuously data is coming, the latitude, longitude, date, time, altitude, speed. I'm not moving much. So, and also right now you will see there is deviations in the speed. You will see it is because right now outside there is clouds, and like too much airflow is like wind is going on, and so many changes are there in the wind. That's why speed is currently right now it is wrong. And let's see other stuffs, like when I move. Yeah, now I am moving, and we will see the changes in the latitude and longitudes. You can see continuously the time is being updated. And now I will take it at high and see the changes in the altitude. Since I am standing at a place, some minor corrections in the, like in the data are expected, but it's perfect. So now the next thing is, I will receive these parameters uh, to another portal, like trace car is a portal, and IoT portal that we are going to develop. In that, what we will do is we will subscribe to these topics, and then use these topics to plot the location of the vehicle and plot other stuffs. So see you in the next video. So here, one thing we have successfully completed, that is, right now we are not sending the AT commands to it. All the AT commands related work is done by ESP32, and we are just looking at it. And the next project will be is to get it on dashboard panel of some IoT dashboard. There we will look at it, and we will do the full testing of it. And thank you.